Okay, so let's take a look at this problem. We got f of x is equal to x natural log of the absolute value of x. And from negative 2 up to positive 2. What in the world is it asking for? Relative min, relative max, inflection points. Okay. Well, this would be my the quotient or product rule. That's p and that's q. So I need p prime. The derivative of x is 1. I need q prime. The derivative of natural log of x is 1 over the absolute value of x times the derivative of whatever's here. So times the derivative of the absolute value of x. Okay, well, we got two cases. First off, if x is x can't be 0 for one thing, because if I put 0 in here, I get natural log of 0. So if x is greater than 0, it means it's positive, then this becomes 1 over the absolute value of x times, actually, I'm lying to you. If it's positive, I don't need these absolute value bars, so they drop away. Times, and if these absolute values are gone, this would just be x. The derivative of x is 1, which would give us 1 over x. Now, if x is less than 0, it means it's negative. Then I could rewrite this as 1 over negative x, because if, let's say, x is negative 1. If I put a negative 1 in here, negative 1 gives you a positive 1. Times, and same thing here, this would be replaced by negative x, and derivative of negative x is negative 1, which would also give us 1 over x. So it appears like, based upon what we just said, that no matter what, our derivative is 1 over x, assuming x is not equal to 0, which it can't be in the original domain. Okay, so we got p prime q plus p q prime. P prime was 1 times q, which is natural log of the absolute value of x, plus p, which is x, times q prime, which is 1 over x, which is going to give us natural log of the absolute value of x plus 1. Set that equal to 0. So we're going to have natural log of the absolute value of x. Take the 1 over, gives me a negative 1. Now the base on natural log is e. So we're going to have e to the negative 1 is equal to the absolute value of x. So we'll have 1 over e is equal to the absolute value of x. Now our formula says that we drop the absolute value, we set it equal to positive the other side. We also set it equal to negative the other side. See how they have 0.37 and negative 0.37? If I plug in 1 over e into my calculator, guessing it gives it to us, 1 divided by e, 0.37. So we're going to have x is equal to 0.37, and we'll have x is equal to negative 0.37. Now if I do my table here, clear over here is negative infinity. Okay, let's try it again. If I put the negative here and I put the positive here, clear over here is negative infinity, clear over here is positive infinity. Choose something less than negative 0.37 like negative 1, something between negative 0.37 and positive 0.37 like 0, and something greater than 0.37 like 1. These are our test cases. We want to plug them into our derivative. Now if I plug in -1 here, we got natural log of the absolute value of -1. Absolute value of -1 is a positive 1, so ln of 1, which is 0, plus 1 is positive. If we put 0 in there, um, 0 is probably a bad one because we said that's not in our domain. Okay, let's try something else. 0.1. If I do natural log of 0.1 plus 1, what in the world is that equal to? 0.1 plus 1, that's negative. So this is increasing, this is decreasing if I put 1 in there. Natural log of 1 is 0, plus 1 is 1, so that's positive, so that's increasing. So this will be a max, and this will be a min. Now, where they get the second values at is they then take the 0.37 and negative 0.37, plug it back into the original function, and see what the y part is. Now the inflection. See, here's our derivative here, so our second derivative. The derivative of natural log of x is going to be 1 over x. And I appear to drop the absolute value because we already justified that up here. And that drops away. So my only critical value would be x is equal to 0, where we said our denominator equals 0. But we already said you can't have natural log of 0, so that's not in our domain. That's why the inflection point does not exist.